Hello and welcome. My name is Joy Ruff. Thank you for joining today's webinar, Create Low-Cost Sandbox Environments with API Simulation. Today, you'll learn how to create and use a sandbox for application testing. Before we get started, I'd like to give you some tips for using the GoToWebinar interface. All attendee lines are muted. You should see the control buttons in the upper right corner of your browser window. You can submit questions to the presenters using the questions box, and we will go through those toward the end of the session. If you have any other questions or issues, please submit those in the questions window as well. As always, we will send you an email after the event and provide the link to the replay, and it will also be posted on our website. Today we have two presenters that are going to share with you. If I can get this page to turn. Okay, all right. We have two speakers. Grigory Trofimov is a senior solutions architect with over 5 years at Parasoft, and he's based in our California headquarters. Rix Grunboom is the strategic innovations manager with over 15 years at Parasoft in our Netherlands office, and they are excited to share today's topic with you. With that, let's get started. Over to you, Grigory.
Thank you, Joy. Today we're going to talk about API sandboxes and how to simulate them. But before we get started, I'd like to take a step back and talk about why we need API sandboxes. And it really all goes back to sales. As a part of the sales role, we understand that a sale doesn't end when the cash hits the bank. Post-sales is just as important as pre-sales. Customer experience is just as important as pre-sales. In fact, customer success is what drives revenue, and there is ample data to show it. Khalid Saleh of Invest actually did a fantastic infographic on this, and there's some key takeaways there. And the first one is that acquiring new customers is 5 to 25 times as expensive as retaining an existing customer. And this totally makes sense. With marketing, advertising, lead generation, prospecting, there's a tremendous effort associated with reaching new customers. The probability of selling to an existing customer is 60 to 70%, while the probability of selling to a new prospect is 5 to 20%. This data is from 2015, so with recent events, you can assume that this difference is even more significant. And increasing customer retention rates by 5% increases profits by 25 to 95%. So average customer retention rates vary across industries, but for most industries, average customer retention rate is below 20%. In the media or finance industries, retention over 25% is considered above average. In the SaaS industry, it's 35%. So no one is saying it's an easy 5%, just that it still makes a significant difference. Basically, customer success is everything in sales. It means you have a good product. It means you're getting free leads, shorter sales cycles, and higher conversion rates. But what does that mean for platform providers? Well, for platforms, tools, services providers, it means that they really need to focus on onboarding. In general, onboarding customers to your platform means getting customers up to speed with your services and using your tools like pros. For a modern API economy, onboarding customers mean teaching your users how to use your APIs so they can build their own solutions and applications. A good onboarding process needs to be transparent and seamless. Developers don't want to put untested code into production, so to build these integrations effectively, developers need and must have some kind of dev test sandbox environment. In general, your customers are going to be very excited to use your newly acquired tools. They're excited for the new revenue it will bring to their business. They want to get up and running as quickly as possible, and they rely on you to be ready for them. And keep in mind, with a poor onboarding experience, you'll be making a bad impression with your customer. And that's one of the main reasons why customers leave and never come back. So if you're in the business of APIs, the key to sales are good API sandboxes. But what is a sandbox and what makes a sandbox good? Well, for today's webinar, we've boiled this answer down to 4 primary requirements, and this rule of 4, you may notice a pattern in our presentation today. But first, let's define a sandbox. So a sandbox is a test environment where developers can put unproven code and try it out before it goes into production. That being said, Number one, APIs need to be well built. Your sandbox needs to be well built. Your customers don't want to see unexpected bugs, inconsistent, unrealistic behavior, errors. The expectation is that your sandbox environment undergoes the same rigorous testing as your production and your QA environments do. Number two, they should be well documented. APIs are not simple, but developers should know what they are doing and what they're looking at when they're inside the sandbox. Swagger and OpenAPI have become a must in terms of documenting and defining APIs, and all services and their respective versions need to be documented accordingly. Not only that, as a part of item 1 in this list, you should be validating that the behaviors of those APIs actually adhere to the schemas defined in your definition, as is the expectation from the end user. Your sandbox should be readily available. Waiting can sometimes be a good thing, but in this case, it's not. And your customers are eager to go. So not having access to their sandboxes puts a significant blocker on your customers' dev and test work. And simply put, any amount of downtime can contribute to a negative experience. Finally, sandboxes need to be secure. In the world of PCI and GDPR compliance, security can mean a lot of different things, but in the context of your API sandboxes, you should be using exclusively test data. And even with test data, customer 1 should never have access to customer 2's APIs, nor their data. Everyone should be sufficiently isolated from each other and really not have any ways of running into one another down the road. Again, a good sandbox is crucial to customer satisfaction. And there's a reason why there are dev portal lists, awards, and many organizations are putting a lot of effort into making it a good and seamless experience. Okay, so sandboxes are good, but what's the problem? Why don't we just stand up a bunch of environments and everybody's happy? Well, it's not that simple. So APIs on their own don't do everything by themselves, right? Real invocations of APIs require an orchestration logic that integrates with multiple internal and external services and backend systems and provides data via a single point of query. So standing up a sandbox environment for a single API means standing up the whole environment, not just a single service. And this can be difficult. There are 4 challenges, which can be conveniently mapped to our good sandbox requirements. And so we can call them the ABCDs of sandboxes. And that's accessibility, behavior, cost, and data. And for the first one, accessibility, simply put, dev tests require stability. Many organizations struggle with their own QA environment stability. Standing up another environment, maintaining it, delivering near 100% uptime is frankly unrealistic. And we know downtime leads to a bad user experience. Behavior, well, a sandbox environment should be a faithful representation of the real system. Static responses are good for simple stuff like gets, but once you start looking at posts, puts, deletes, those all require some change of state and dynamic logic. Not only that, what happens when a customer wants to test against delays or do some negative path testing? Well, these conditions can be very difficult to control or simulate in a complex system. As far as cost, simply put, standing up and maintaining an environment is not free. External dependencies add to this cost. The more users you have, the more those costs will scale. And so now actually understanding those costs and understanding the usage becomes crucial to whatever pricing or chargeback model you may want to implement for your end users. And finally, data. So the test data in a test environment is a lot like a coin machine. If you're not familiar with a coin machine, it takes your coins, it counts them, it returns some amount of cash. But if multiple people are using the machine at the same time, it still does what it's supposed to, but nobody knows how much cash they're gonna have back. The same thing happens with shared test data in shared environments. Once data is consumed, it's no longer, it can't be used anymore for other tests until those changes are reverted in some way, which can take a lot of time when there are a lot of moving pieces in the system. These are challenges we see in many organizations who are also looking to improve their testing and test automation practices. And frankly, the solution here is rather similar. So Cue service virtualization. Service virtualization is a method to emulate the behavior of specific components in heterogeneous component-based applications, such as API-driven applications, cloud-based applications, and service-oriented architectures. It's a powerful solution when it comes to API simulation, stabilizing test environments, and enabling rapid agile development. It makes sense why it would be a good choice for low-cost sandboxes. Service virtualization provides you with the ability to stand up complex environments on demand, build realistic services and controlled individual service behavior, administrate and keep track of usage across all of your sandboxes, and finally, it allows you to create and manipulate data for each unique API and for each individual user. As you can see, service virtualization really checks the boxes. So with that, I'm going to turn it over to Rix for a hands-on presentation. Rix, take it away.
Thank you, Gregory, for this good introduction into the topic. And let me indeed take you through the different type of topics that we want to do. So for the first topic is how can we actually do the provisioning and provide you this complex sandbox environments. So in a way to offer this this capability to our customers, let's say in the first place. Now to do that, I have to give you a little bit insight of the architecture of the demo application that I'm about to show you. The sandbox environment consists of kind of this, can almost call it this pipeline. On the left hand side, you see a screenshot of the API that's in the end provisioned and provided by the sandbox environment. This is through a gateway protected to the actual server, the virtual server that is hosting this API, and the API itself is driven by a data repository holding the data that has to be supplied when these invocations are being requested. In the course of this presentation and demo, I will refer to two personas. One I refer to as Alice. Alice is actually the business partner of our application. In this moment, we pretend we are a bank that has to provide through the open banking an API to the outside world. So Alice is a business partner of the bank, and she wants to consume the API, and for her own testing needs, she wants first to do it against the sandbox. There is another persona in my story, and that is Bob. Bob is actually an engineer working at Parabank. It's his responsibility that this sandbox environment is up and running, and also that the provisioning with all the requirements that Gregory just mentioned are being satisfied. So with this reference picture, I will now take you through this first requirement, Gregory, where you see, can we spin up such a complex environment and actually get this sandbox to life? So let me take you there and bring you to my browser that actually hosts the different applications. As mentioned, we are simulating a bank, and this bank actually has also an internal API, and people who have worked with our technology before knows that Parabank is actually an application that we provide with our tools. And Parabank is a very rich API. You can think about it as the internal API of the bank, which holds all the customer data, which holds access to a database, maybe JMS, can restore individual transactions. It is a very rich API. Now, in our example over here, we said, well, under the open banking, or in Europe, it's the PSD2 requirements, we are forced by to provide a certain subset of these operations to our end customers, to Alice. Now, that thing I have nicknamed here Parabox. It is the sandbox environment of Parabank, and that gives a limited set of all the capabilities, but enough for Alice to do her work. And that should be the only insight she had to our operations. And these interfaces, these APIs, they should give the indirect access to the database, because she doesn't need direct access to the database. That's for internal applications. So what we see over here, the subset is we have an authorization operation with a login that we're going to try out, because of course you're curious. Of course, I can access customer data. There is, and that's the core capability of this open API, there is a possibility to do stock operation. That's actually the core functionality. And we come to this aspect later. There's also a management operations on the sandbox itself. So as you can see, this is a subset of the large set we had internally available, and this is the operation that we will provide in production, and for Alice testing needs we have it in this sandbox. So let's then take a little look what we can do. Now we all have an intuition with a login operation. So this is Alice executing a test case, and where she wants to retrieve, for example, the data of her customer John, which she knows should be available in this sandbox environment. So she can actually perform this invocation. In this case, I do it through the tracker page, and indeed you see the record is produced of a user that lives in the data set behind the API. There's an important number that we need to remember. This is the customer ID, because I need this customer ID for other operations if I want to do specific operations on this data set John. Now, as I said in my architecture, this data coming from a data repository server. It comes from somewhere. Also, that one I can access through this interface. And as you can hear here, I have, for example, the customer table, and to see actually the record where it's the user 111 is stored. Here you see the data of this user, and for example, also its internal customer ID is also stored in that data structure. So hopefully this gives a small impression on how actually we have now a live sandbox environment with a Swagger definition, and we can actually invoke these different services through the API. Now, the login, of course, is a very simple operation. Later on, we want to do more complex stuff. And for example, let's see if we what we would get if we now directly for that customer. And since we now know his customer number, which was 111, let's retrieve the data for that person as well. And as you can see, also through this API call, I will actually and can achieve that type of data. Now, that, of course, also in my with my testing hat on makes me curious. Is it then also possible to change the data for that customer? So yes, I can. So I can, if I would like, change the data in the underlying database. I will leave some digital gravity. So I will give John a different first name that is easy for me to remember. And if we now would retrieve that data set, we would see that now actually the new data from the data repository server is already provisioned automatically and is exposed through this API to, in this case, Alice, performing a test case on a user who now actually has suddenly a new first name. Yep, so far so good. And let me bring you back to where we were in our overview. Over here we see that we have been able to provision a sandbox environment and all the different important components like serving the YAML file, the definition file, having the different operations, and have them meet data-driven gives me the core capabilities of what I would expect from a sandbox environment. Having said that, this is kind of not enough. You already mentioned it earlier, Gregory. If you want to have a serious sandbox environment and services, they're often data-driven, and means not only you want to have like in this case, a response that comes out of a database, but you also have operations that would actually change the data. And if you then invoke that data again, you would like to see the new data that you just stored. So somehow you want to see how you can build realistic services and have these the behavior of this data of this sandbox indeed completely data driven. Now, so let me also take you through that aspect of how that would work in our sandbox. So I go back to my application, which of course we remember very well. But besides the get operations, I'm now far more interested in an update operation, which it's technically done through a post. So I want to post some data to the service and then have the service consume that data, actually use it to update the database. So if I would later do the get, for example, from that same user, I would get this new updated, for example, address information of that person. Now, so let me do that. So instead of only giving my first name, I will give my full credentials to this bank with all the required details, and I would try it out. I would upload the data, and if I would go back to my get, and indeed for the same number, which I'm of course using this for this demo extensively, you see that I don't only get my first name, but I have my full record being updated in this database. Now, of course, I already have some more confidence that it will work, but let me still take you through the data set. I was working on this customer 111. and if I take a closer look at the actual record as it's being stored in the data repository server, you actually see that it's now completely overwritten, or should I say updated, as a consequence of the post operation that I've done, that Alice actually has done through the Swagger interface. Now, this is one example of how, but I think a very crucial one. The fact that we can actually do this hopefully proves to you that if I can change data, then I can also remove data, or maybe even create data if that would be an operation offered through my API. So this suddenly opens up a whole aspect of modeling real complex scenarios, similarly as you would expect from, between quotes, the real application. At the same time, this gives me a architecture question, because how far should I go with this type of modeling? Things don't happen automatically. So at a certain moment, also with service virtualization, although it gives you a very powerful toolbox, you have to do work to let it behave for the interface that you want to simulate. Now, if I look back on the engagement that I've done, I've observed a kind of 80-20 rule. There are situations where a static response, a kind of mock service, is good enough. Yeah, that it's fine that you get an answer. It's almost like a technical ping. You get an answer, you get some detailed data, and with that you can continue the flow as long as you get a syntactic, would say, correct response. Now, modern API gateways have very good ways to store these predefined answers. You can call them mocks. So if that is really what you need, it's sufficient for you, as in your role as Alice, to have fixed responses, then I think service virtualization would almost feel a little bit like overkill. And on the other end of the spectrum, you have a different question. It could be that the operation that you do through the API actually will require or will update real backend systems that are somehow connected to specific records that really invoke the real backend systems. So if there is so many dependencies on the other side, then you really have to consider, do I want to replicate that data? Do I want to build simulators in the technology to replicate it? So if you come into that situation, I really would advise you to think twice. And since you already have the APIs in production, you can also clone that and bring it under the as Sandbox environment and expose it that way to your customers. There is, of course, as Gregory mentioned earlier, a serious cost associated with that, because a complex environment is a complex and potentially expensive piece of equipment. However, in those situations, I would really reconsider twice service virtualization. That sounds all very bad, but it's not. I would say in about 80% of the cases, I've seen the power of service virtualization being sufficient to build realistic simulators for testing and validation scenarios. So service virtualization is the technique to build sandbox environments to serve APIs for your customers. But I want to give this kind of, from my own experience, this data to share it with you. Where would you like to see, when you have to think about using service virtualization as a mechanism to build your sandboxes? Okay, Gregory, that I would say would be my answer to your second point. Besides that, you have the capability to serve answers, the fact that you want to have them dynamic, that you have the ability to do data manipulation, requires certain capabilities. And when you do this type, where you go into this path, you do have to consider, am I on the right track? But I think with virtualization, you have a good chance of building cost-effective implementations. That brings me to the third point, because at the moment the focus was really on giving functionality for your end users, for Alice, to be able to do the work that she needs to do. But we also should not forget Bob. Bob has the responsibility to actually provision these sandbox environments and to administer these sandbox environments, because they are actually a real service that you offer to your customers. Often these sandboxes are almost part of your official delivery. They are normally also seen as production environment systems under an FDA. So there is serious scrutiny required for a sandbox environment. It is for testing purposes, but not of your own, but of your business partners. And that they use it for testing is not your concern. For you, it's actually a production system. So that you're able to do this in a good solid way, and that you have the ability to track and trace what goes on this environment is very important. Now, what is the basic type of things that Bob needs to do? Bob, of course, has to see and to keep track if all the services are up and running, if there are no exceptions, if the server itself still has enough capacity, if it's not running out of memory, out of disk space. I would say basic, not basic as not important, extremely important, but basic system administrative capabilities. And next phase would be to see more the usage of the sandbox environment. So not so much the technical aspects, but more the functional aspects of the sandbox. Are the messages that we receive from Alice, are they correct? Is it clear? Do we in a correct way respond to them, or give them all kinds of, let's say, XML validation errors, and therefore we get strange behavior? And besides this, reacting on request response pairs, there's also another type of question that we want to monitor. Do my business partners, does Alice, in her case, send the messages in the right order? So are there workflows that we expect? For example, first we expect a login, and from this login they will drive the customer ID, and from the customer ID I can actually get customer data, and from the customer data I can do an update to my stock positions, for example. Are these flows actually being respected? So the more functional aspects of what goes on the sandbox. And actually that leads me to a third, more advanced uses of sandbox environments. Once you are at that stage, you could also try to validate these responses. So not only check that they're being done, but actually really validate, almost test if people are using the sandbox of the workflows modeled in the sandbox in the right way. And this will lead to a possibility to actually certify your end users. And that is a very interesting concept. So then you could say, yeah, I want you first to respect the SLA and actually prove that you use my API, in that case, in the sandbox environment. And only after you've proven that, then I will allow you, dear business partner, after you went through your initial onboarding process, and only then I will allow you access to my production systems. And another aspect of that might have some SLA and potentially some financial implications. If people start to heavily use your sandbox, or should I say heavily abuse your sandbox, then there is maybe some agreement that you have in place that there is some monetization, some charging for the use of the sandbox environment. And for that, of course, you have to be able to analyze the traffic very closely, who is using which service, and where and how often. I've seen cases where people used a more functionally intended sandbox environment for their own performance testing, for example. So Alice thought, hey, that is a good idea. Let's use this sandbox also for my performance testing. Although that is kind of fine, it will, of course, potentially give Bob in a difficult position, because if this server gets hit very frequently, he might have to increase, for example, the size of the Docker container running the service. And now that's something you might want to at least to monitor, and if things go out of hand, have a discussion with your end user, with your business partner, if that was intended or unintended use of the sandbox environment. So Gregory, yeah, that's kind of addresses my my response in this sandbox on how you could do the administration and the control in Bob, in his responsibility of keep the sandbox environment alive. Then we come to the fourth point, which kind of was your example of this coin machine. Something you know in the US, we don't have so much here over in Europe, but I found it a very appealing model. Is how can we make sure that if we have potentially more people, so besides Alice, also maybe we have a Chantal and Erica or Joy who also would like to use the services. So how can we help customers so they get their own impact? So could you give us a little insight in your ideas on that?
Thank you, Rex. Yeah, so let's talk for a second about the overall architecture behind an API sandbox. The main point of entry for Alice, the end user, is going to be the API gateway. And there are many reasons why this is a good idea, but for one, you're probably already using an API gateway to connect and route and catalog all your real APIs. So it only makes sense to do the same with these simulated services as well. Not only that, it will handle important security functions like authentication and routing, which means that Bob, all we have to do now is focus on simulating the service and making sure that it behaves as expected. For that, we have the virtualized server, and there we're hosting a golden copy of our virtual service, or Parabox as we've predefined it, and its corresponding golden copy data source. The service can be deployed on its own port, custom URL paths, and as we'll see here in a second, its own server. And what's nice about the data repository is that it's completely separated from the service. So any changes to one doesn't actually affect the other. If you need to reset the data, you don't have to make any changes to the virtual service. If you want to update the schemas in your virtual service responses, no need to update the data. This modular approach also enables data sharing across multiple services for complex API groups. So when customer 1 requests access to a Sandbox, API gateway authenticates Alice and routes her to a cloned version of the golden copy services and data sources defined by Bob. Same thing happens when customer 2 requests access. API gateway takes care of the routing. Suddenly we're supporting multiple users without having to do any extra work. Now a third customer wants to integrate their application for some end-to-end testing. They can do that as well with their own unique data. Now this solution can scale beyond a single server. So say you want to segregate these sandboxes out even further. Parasoft solutions are agnostic, so they can be deployed in containers, AWS, Azure, etc. And each customer can have their own containerized API sandbox, all cloned from the golden copy assets predefined. This model enables deploy and destroy the testing models, or if you want to use something like Kubernetes for orchestration of these deploy and destroy test environments, really opens things up for various scalable, effective and scaled out architectures. The architecture is efficient, but it also enables the administrator, Bob in this case, to expose some really nice self-service controls to Alice. These are just a few common examples, but operations such as reset data are a must-have. Ability to set performance parameters to validate your application behavior with response delays, absolutely a must-have. Ability to inspect existing data as well as the ability to upload your own data sets are all great, and they all contribute to a fantastic end user experience, which is really the main goal here. So with what does that look like? Rix, I'm going to turn it over back to you here.
Okay, Gregor. Yeah, thank you for this. I would almost call it for this challenge. So let me actually take the challenge. Actually, start, for example, with the last one, and then actually give a little insight in how you could also do this. I would call it this cloning of these sandboxes and these what you refer to as the golden copies. But let's first take us through the situation where we were. Remember, we had this data set, we had done some extra work. In this case, Alice uploaded the digital graffiti, and now she needs to reset the data because she has another regression test that she started. This regression test requires also the APIs through the sandbox to be in their original state, and we want to undo some changes that we've done. Now, the classical way would take the telephone and call Bob and ask Bob to reset the database. But of course, that doesn't scale very well. And in particular, is Alice in this very modern, very agile way of working, potentially completely CI/CD. She would like to have the capability of doing that also in an automated fashion. Now, in the beginning, I already mentioned that we have supplied the sandbox with some of these management operations. So let's take a closer look. Now, for example, the set parameter would be ideally to use what you just mentioned, Gregory, that you can set also non-functional aspects, non-functional properties of your sandbox. For example, adding artificial delay, or potentially even making it temporarily not responsive to do some resilience type of testing on behalf of Alice. But let's take a closer look at the reset sandbox, because that is something that we could easily relate to. So in this case, as I said earlier, the use case would be Alice did some real testing, so did some updates in the databases, and now she wants to reset the sandbox because she wants to restart her regression testing with a clean set of database. Now, by doing this, by calling this service, what she actually does is she asks the sandbox to reload the data in the data repository with the golden copy that was originally there when she for the first time got access to the sandbox. So I've executed that API call, and I think the best way to see if it actually worked would be to go through the we get customer data, and of course we're still of course working with customer 111. Try it out, and actually I see indeed that the data of my customer with customer ID 111 is reset to its original state. Now I think you already trust this, but always let's verify it once more. Before I did the transaction, this was the state of my service. If I will now ask it to refresh the data, so I take another look into the database, I see indeed that without having to do any manual intervention, the data was completely set to its original state. And this gives, in this case, my end user Alice the capability of doing this type of testing without that she actually has to inquire any assistance from the administrator of the Sandbox environment. Now, besides this reset, you can envision that you can also offer more advanced capabilities, not only resetting Sandbox, but one thing you could do, they can even ask you to upload your own data set, for example, and then that's a bit how much on Bob to the side, how much flexibility, how much capability they would like to offer to the users of the Sandbox environment. So that is still in the fashion where you have a user. But you mentioned something interesting, Gregor. You might want to onboard also other people besides Alice. And for example, the users that you had with the different colors. I remember you had the orange, the green, and the purple. Now, to show that I can demonstrate it, but there I'd have to give a little bit more insight in how actually the Sandbox environment is working. Up till now, we went everything through this API call, and I gave a little insight in the data that sits behind the service. And I didn't pay a lot of attention, but actually I went always into the Sandbox data repository server. This actually is I would call it the white user, the original user, the first one that we exposed and that we gave to Alice. Actually, there were already more sandboxes running on this same server and the same database. There was already a set of data for a user green and also user orange. Now, I will now later on in my use case want to add a fourth one, which is the purple one that you had in your slides. So therefore, of course, I somehow have to make sure that I replicate and create a new data repository instance that has the data, but also have to make sure that the server definition itself is redeployed. So through this step, I can get a little, I'm Bob, don't forget, I'm Bob at this moment. I can see a little insight in where the server stands. And also here you can see, I already have 3 message proxies running. They're each connected to the gateway on the individual ports. And we also have the implementations, the green, the orange, and the original Sandbox already working on the server. So this gives you a little insight in and how on the same server we have these 3 server definitions running in parallel, and through certain different ports, these ports are exposed to the outside world. Now, to show you a little bit that we actually do something that was not possible in the beginning, I will go back to this user interface. Now you have to notice a little bit at the moment, the white data source runs at port 9080. I have already deposed the orange one on 9081. So if I would go to the 9081, I would be served with the same page. There's also for the green one, I have it exposed on the 82. And for the purple one, I would like to have it on the 83. So if I would invoke that one, then I expect indeed what I would expect. At the moment, I have not onboarded this purple customer yet. Okay, so for that, I have to do some work. Now, for that work, we have created a management console that Bob can operate to duplicate the process, or to execute the process that you do set, and able to replicate and to duplicate the different aspects that are required. That is a proxy to connect it to the API gateway, the service definition itself, and so the virtual service that's actually doing the API, and of course the data repository server. So we have also the separation of the data aspects. Now for this we have a clone Sandbox operation, which I can execute, and of course I have to tell it that my new customer will be called purple, and of course the preferred port on which I would like to have this service deployed. As an aside, I will now do it actually from this UI. I will execute this step manually, also to take you through the process happening, but nothing prevents me to do this also in an automated fashion. So that's actually a curl command that I could execute. So I could also teach another tool, a CI/CD tool like Jenkins, for example, to do this task for me. But just for that, I will now do it manually. And as you said, on the background, there are different tasks now being executed in parallel, and we can already see some actions going on. For example, we will see, and if I reload the data repository server image, that we're going to see that this purple sandbox is already being populated and available on the server with the default set that we already know, already know quite well by now. So that is standing and there. The second thing that happens, we have to get a new instance of the virtual services, and also there we see that if I refresh this window, that besides the green, the orange, and the white, I now have a new entry point, the proxy on the server, which will be listening, and I will double check that in a minute, on the port 9083. And you also see that also a new directory is created in which we have both the sandbox and the tracker definition being ready to be served through the new user, which now of course is not Alice anymore, but another user that is there. So to demonstrate to you that actually physically this service is now up and running on this sandbox, I would now want to re-explore this port. And previously it was not available. And then now we would explore this on this endpoint. You actually see that here is now an operation up and running. I have the operation that I expect. It is of course loaded with my default data because it comes from the golden copy. So for example, I expect my user John to be happily also available in this data set. And we can start to do all operations now for the purple user instead of the white user that was Alice in the previous part of my demonstration. So getting back to the slides here, Gregory, I think we've passed already these 4 different aspects that you mentioned. And for the first one, and I like this example of this coin machine. If you have too many people knocking at the same front door, so you really have to be able to have different ways to separate the data, for example, by snapshotting, resetting data, and potentially also generate fresh data sets. So these users can all work in their own instance of the sandbox. You can almost call it in their own swim lanes. So with that, Gregory, I would like to give the word back to you to wrap up the things we've seen so far.
Thank you, Rix. Fantastic presentation there. So to recap, having an API sandbox for your customers and partners enables a smooth onboarding experience. Again, the name of the game here is customer success. Real services need the whole environment to work properly. This is why virtualizing individual services reduces the complexity of an API sandbox. Sandboxes should behave like real services, and Parasoft Service Virtualization offers a rich feature set to replicate the behavior of real services and validate the behavior of virtual ones. Sandboxes should be low cost, and we talked about the sweet spot of service virtualization effort versus return on investment. Finally, sandboxes should be scalable and secure. Parasoft offers a variety of deployment models and enables multi-tenancy via a modular-based approach to service virtualization and data management. And just to wrap it up, this is something Parasoft has done with existing customers. This is something that we've successfully applied in Vital API infrastructures across financial services, energy and utility services, and healthcare. With that, I'm gonna turn it over back to you, Joyce.
Great, thanks so much. And thank you both for the awesome presentation and demonstration. We would like to invite you all to join us at future events. You can find out more about future events at our website, parasoft.com. You can request a demo at info@parasoft.com. Additionally, if you'd like to learn more about service virtualization and sandboxes, We invite you to also read a customer case study or to download a free copy of the community edition of the virtualized tool. You are also invited to join us for our upcoming event, the Automated Software Testing and Quality Summit on November 17th. At this special event, industry leaders will be sharing their experiences with improving software quality with test automation. So now let's respond to your questions. Grigory, Rix, where would you like to start?
Sure. Thank you, Joy. I might go ahead and kick us off. So we got some questions here. Can these sandboxes be containerized and orchestrated with Kubernetes? What about deploying on dynamic cloud infrastructure, e.g. Azure? Yes, absolutely. So it was, I think, one of the slides there that we showed. Our solutions, Parasoft Service Virtualization Solutions, the virtualized server is really agnostic of where you want to put it, whether it's in a Dockerized container or AWS or Azure or somewhere on-prem. We support all those flows. As a matter of fact, having that flexibility is really what opens up the different options for architectures for a scalable sandbox solutions here. Another question is, can sandboxes definitions be shared, or do I need to host them? Yeah, absolutely. So the assets themselves, the virtual service, the data repository, everything can be exported, can be checked into source control. So in a clone asset workflow, for example, those assets can be in data repositories, can be pulled from Git or your source control management system and stood up in that way. They can also be shared across teams to enable collaboration. On the administrative side of things, for all the Bobs, everybody can have access in different user roles when it comes down to accessing the administrative console and tracking and tracing those sandboxes.
Hey, Gregory, I see here another question. I think I would like to take that. There's also one, it's a bit overlaps with what you said, but can they also be used into the cloud, for example, in Azure and Amazon? And besides that, technically we can do that because we can run them in a Docker container. This actually opens up also another use case, because at the moment we are very focused on that Bob runs his sandbox in his environment. But nothing in a way prevents you, once you have this definition ready, that you spin off a cloud instance and actually give access and give that complete sandbox environment to your end customers so they can use it over there. So that was almost a next step in providing this capability extremely flexible to your end users. And even then you give them not only the access, but access to the technology, but actually give them the whole sandbox so they can operate it internally and potentially even use it for their internal testing and duplicate it maybe even for their own usage. So then we really stretch this whole concept of flexibility even one step further.
Okay, great. I think I saw another question come in. Grigory, I think this one might be for you. Does Parasoft have a way of validating the JSON schemas against the sandbox?
Yeah, it's a fantastic question. Thank you, Joy. So yes, absolutely. And one of the things we mentioned with regards to what makes a sandbox good is properly defined sandboxes and making sure that those schemas actually adhere to the responses that Alice is getting back from those services. Parasoft's functional testing solution, SOATest, actually has something called JSON validator tool, which enables users to validate their JSON schemas against the response payloads based on what's defined in their Swagger or their open API definition file, which is really important, because if a developer has access to, if Alice has access to a sandbox and it's returning type string, but in the definition file it says it's returning type int or something else, all of a sudden there's there's a mismatch. There's a miscommunication there. Well, which one is the correct one? How should Alice build her integrations? In that case, you want to validate these responses prior to launching these sandboxes, and those are things we can do with Parasoft functional testing solutions.
Wonderful. Well, let's talk a little bit more about the Parasoft capabilities. There's a question about, does Parasoft generate data for you?
Rix, did you want to take that one?
Yeah, I think I was about to answer. Yeah, Joy. Yeah, now Parasoft, of course, Parasoft, we provide this technology. So Parasoft, Parasoft as the company, of course not, but the Parasoft toolchain that we've shown has capabilities for different aspects. And one was this data repository server. And there, indeed, with Parasoft tools, you can actually generate data. And that was a little bit. That would have been going too far to also show that in this webinar how we actually populate the data and how we generate the data into the data repository server. But that can be done in many ways. For example, a very powerful way is actually recording data from real traffic. Potentially also in this case, you also have real services in production, or so that's Sandbox services. So that could be a starting point to record data, generate the schemas. And I think, Gregory, you were really right earlier to say, well, you have to make a split between the logic that you put in the service and the data. And that is a really important architecture decision. And since you do that, that suddenly gives you the capability to generate new data and does not require you to change the actual service definitions. So yes, with Parasoft technology, in this case, the data repository server and the environment manager component, you can generate data.
Okay, excellent. I see another question here about the Sandbox in this demonstration is based on HTTP REST. Do you also have support for other protocols?
Gregory, let me also take that one, because I've been in real situations where indeed we also had to handle other types of interfaces. You mentioned a few of the use cases, and for example, in the open banking, in the financial world, you see people really using the modern, the REST, this correct HTTP JSON type of formats. But if you look at healthcare, or for example, the utilities world, there the APIs are not REST APIs. They can be very I would almost call them classic EDI communication, for example, where you exchanged fixed length messages, or for example, use file transfer, FTP, and those are also ways to define an API. They're not REST, but yes, to answer the question of this, sir, you can indeed model with the virtualized the Parasoft technology also more, what's the right word? Traditional protocols also that go beyond HTTP, and that can be email, file transfer, and also on the payload side can be something far more potentially difficult to handle, like EDI, Swift messages, etc. So it really depends on the industry, what type of capabilities are required.
Great, thank you, Rix. Looks like we have a follow-up question about the data, or kind of related to that. We have a question: can I call a web service or make a SQL from Parasoft? For example, virtualize a web service with Parasoft and then put some data from Parasoft to a database.
Yeah, absolutely. I can take that one. So, again, absolutely. So, Parasoft solutions enable users to communicate with databases in a number of different ways. Whether you want to query a database and pull data from the database, or you want to query a database and upload data to your database, or if you want to virtualize the whole database and create a virtual instance of the database for your virtual service. All of those operations are entirely supported, and I think that kind of generally answers the question. But yes, absolutely.
Excellent. Thanks, Gregory. Okay, I see one last question at this point. If anyone else has questions, please do feel free to enter those in the questions box. We still have a few minutes left in the session time. The next question is, you showed a lot of use of Swagger. Can we use different versions of Swagger files for updating the virtual services?
I can take that question as well here. So Yes, and again, this goes back to one of our requirements that we defined for a good sandbox, right? Is proper documentation and documenting your APIs through various versions. Well, if you have corresponding Swagger definition files or Open API definition files for version 1, version 2, version 3, etc., Parasoft solutions, Parasoft capabilities actually enable you to compare the two definition files together. And from that, not only determine how your existing services were impacted by the changes implemented from version 1 to version 2, but also actually generate a template that will refactor your existing virtual service or essentially create a duplicate of that virtual service with the changes adhering to those applied in the definition file, applied in the definition file. So this really reduces the maintenance of, the burden of maintenance when changes are implemented, again, from version 1, from version 2, version 3, which in today's rapid agile software development life cycles happens all the time. So just another way to save you time and effort when it comes down to maintenance of your virtual services.
All right. Well, thank you very much. That looks like that wraps up our questions for today. Thank you to our audience for attending. Lots of great questions and definitely an excellent presentation and demonstration today from Grigori and Rix. Be sure to register for future webinars and sign up for that automated software testing